In this video, we're going to look at limiting reactant calculations that involve mass. We've previously looked at these calculations with moles. This is going to be the exact same thing as the last problem with the aluminum and the oxygen, but now we're going to be using grams, which again is a little more real world because in the lab I measure in grams. This problem has everything kind of broken down step by step for us. We have nitrogen gas combining with hydrogen gas to produce ammonia. It's often used in fertilizers. How interesting. First thing I need is a balanced equation. So we have nitrogen gas, nitrogen, which is diatomic, reacting with hydrogen gas, diatomic, to produce ammonia. And they tell me NH3. All right, so we need this balanced. I'm going to for sure need 2 nitrogen and 3 by the hydrogen. We should be good to go. Balanced equation, check. First step in any stoichiometry limiting reactant problem. Now eventually, they give me 2 masses. They give me 92.7 grams of nitrogen and 65.8 grams of hydrogen. How many grams of ammonia will be produced? Previously, the first half of this chapter, we were looking at stoichiometry problems that started you with one number. And after you balanced the equation, you used the one number to figure out whatever they're asking for. In this case, maybe it's grams of ammonia produced. The difference here is that we have amounts of both reactants. And I need to know which one to use in order to solve for the amount of product formed. The limiting reactant is the one that is used to determine how much product is formed. When one of those reactants runs out, whether it be nitrogen or hydrogen, I can't make any more NH3. So now if you are given amounts of each reactant, we need to figure out which is limiting and which is excess. And if we're given grams of each reactant, we'll need to switch them to moles first. So that's my first step. Get those amounts out of grams and into moles. So I use my periodic table. It's diatomic nitrogen, so 14.01 times 2 is the mass of 1 mole. And if we go maybe 3 sig figs, 3.31 moles of nitrogen. And then we have some diatomic hydrogen. Cancel grams, we want moles. 1 mole is 2.02 grams. So we'll divide, oh boy, maybe 32.6 moles of hydrogen. Okay, cool. So now here's where we kind of started with that last aluminum oxide problem. They gave me moles of each reactant, and I could use the moles to figure out which is limiting and excess. I like to mark in these amounts. This is what I have. I was given 92 grams of nitrogen and 65 grams of hydrogen, and all I did was change them into moles. So this is the amount that I have to work with. Now I'm hoping that eventually you can get to a point where you can figure out the limiting and the excess by inspection, especially if it's a pretty easy ratio like this 1:3 ratio on the reactant side. But until then, if you want to calculate the limiting reactant, we choose one of those reactants in moles and we'll turn it into moles of the other reactant. So let's say, I don't know, randomly I pick the first one. 3.31 moles of nitrogen. And I just want to do a little switch. If I were to react all the nitrogen, so I cancel nitrogen, how much of the other reactant would I need So we'll switch it to the hydrogen. And then we just insert the ratio from the balanced equation. It is a 3-to-1 ratio. So we plug that in, and we'd be looking at 9.93 moles of hydrogen. And again, for as many of these problems as I've solved, I still like to write it in. This is what I need. Because what I need, I need. And then we do a comparison. What we need versus what we have. I need almost 10 moles of hydrogen. Oh, good Lord, we have like 3 times that. We have over 30 moles of hydrogen. By far, hydrogen is my excess reactant. Which means by process of elimination, the nitrogen must be my limiting. If you calculate the limiting, you honestly only need to do one little mole switch. Pick one reactant, use the ratio in the balanced equation to turn it into moles of the other. That's what you need. Compare it to what you have. We have well over the amount of hydrogen needed. Which again, I think eventually you could just do this by inspection. Check out these numbers. Here's what I have. I look at my ratio in the balanced equation. I need 3 times as much hydrogen. Well, I could figure that out. 3.3 times 3 is about 9.9. Oh, yeah. I have extra. Or you could think of it in reverse. If this is the amount of hydrogen I have, I would divide that by 3 to get the amount of nitrogen needed. I need 1/3 as much nitrogen. It's a 1-to-3 ratio. Well, if I were to take this 32 and divide by 3, I'm looking at approximately 10 moles of nitrogen needed. I don't have that. I only have like 3 moles. So in either direction, if you don't have enough, that's your limiting reactant. And if you have extra, you found the excess. Cool. So this part 3, determine the limiting reactant. You need to determine the limiting reactant, but you don't necessarily need to calculate the limiting reactant. Sometimes they might just say justify your answer, which then I could say, well, I estimated I need about 3 times as much hydrogen as nitrogen, and I have well over that amount. You could just write a sentence to justify the limiting reactant. Why do we care? Because the limiting reactant is the one that's going to run out on us first. This is my excess. So if I run out of nitrogen, I can't make any more NH3. The amount of product will be dependent on the nitrogen. And so when I do my stoichiometry here, solve the problem using the limiting reactant. We're going to go back to the amount of nitrogen that we have. So we really only have this 3.31 moles of nitrogen. I always start with my limiting reactant. And then we'll just do the stoichiometry. Since it's already in moles, we can cancel moles of nitrogen. And we could at least get over to moles of ammonia. We plug in the ratio from the balanced equation, which I better find that ratio. 1-to-2. Okay, so that's a 2, that's a 1. And then technically these moles would cancel. And then often they'll want our final answer back in grams. So then we'll just cancel moles of ammonia and put it in grams. The periodic table will tell me the mass of 1 mole. I just need to add it up. 17.04 grams. And then these guys would cancel. Excellent. Then we can plug it in. 3.31 times 2 times 17.04. And all my original numbers had 3 sig figs, so maybe I'll just leave 3. How about 113 grams of ammonia? There. So the final stoichiometry was the same as anything we've done all chapter. The only difference here is that when you're given amounts of each reactant, we need to figure out the limiting reactant first, because then that's the one that I'll use to determine how much product is actually formed. Now the other application of this, and I got to remember, my limiting reactant is 3.31 moles of nitrogen. Not only does the limiting reactant determine how much product is formed, but it also determines how much of the other excess reactant gets consumed, gets used, gets reacted. So we're going to do something similar now, but we're going to go from our limiting reactant to our excess. Okay, so watch this. I have 3.31 moles of my limiting reactant, the nitrogen. 1 moles of nitrogen, my limiting reactant. We're just going to set up the exact same stoichiometry as the last calculation, but instead of switching to product, we'll switch it to the excess. The hydrogen was my excess reactant. So plugging the mole ratio, it was 3 to 1. Technically these would cancel. And then it does ask for grams, so we'll get this out of moles, hydrogen, and into grams of hydrogen. Oh, we already have the molar mass. That was 2.02 grams per 1 mole. I like it. I can do this. Moles and moles will cancel, and we just plug this in our calculator. 3.31 times 3 times 20.02. Oopsie, 2.02. Which actually it is about 20.1 with 3 sig figs. That's grams of hydrogen. Again, they say consumed, which means that's the amount that was used. It's the amount that was reacted. All those terms mean the same thing. And so finally, the last part here, how many grams of the excess reactant will be left over? So now I go look back up at the problem, and originally they gave me 65.8 grams of hydrogen. That's the amount that I originally have. All we have to do is subtract. We're actually only going to use about 20.1 grams. That's the amount that gets used, reacted, consumed, whatever you want to say. So all we do is subtract. 45.7 grams of hydrogen excess. There we go. So once we calculate the amount that gets used, all we have to do is subtract. Go look at the original amount given in the problem, subtract the amount that gets used or reacted, and that's the amount excess. We got enough hydrogen to run this thing like 3 times. We had over 60 grams and we used about 20 grams. Darn nitrogen, we ran out. The entire reaction stops. The limiting reactant limits the amount of product that can be formed, and it limits the amount of the other reactant that gets used. So the rest of it is just unreacted hydrogen.